this video, I'm going to discuss everything about the summer internship at Emergy. Purpose was to build a smart IoT-based home automation system using Arduino, PixMLab, and Blink application. And this setup will help us to control the lights, temperature of home, inflow and outflow of water in the water tank through Blink IoT mobile app. So in project breakdown, we can see that in week 1, I learned about the technical aspects of C programming, focusing on syntax and control structures useful in C programming. Then in week 2, I analyzed and explored C++ in depth, learning about its advanced features and structures like inheritance and polymorphism. And then in week 3, we finally developed Arduino specific function skills essential for project development. So in C programming, the things I got to learn were basic syntax and structure of the program, control flow, then functions, then arrays and strings, pointers, structure, file input output, error handling, memory management and debugging, and so on. So in C++, I got to learn about object-oriented programming, templates, operator overloading, then exception handling. Then we also got to know about standard template library STL files, standard pointers, and multi-threading techniques. So after C++, we learned about Arduino programming. We first referred the datasheet and learned specific functions related to our project, such as CLCD, LDR, LED blink, serial communication, and learned various functions related to it. So coming to the project requirement, we will have a IoT based home automation system that will connect our controls through the Blink app. So we have the first requirement as garden light control. With the Arduino or the LDR sensor, send the data to the Arduino and it will automatically change the garden light. So in this requirement, we have the requirement as the will use LDR sensor, and in the process we'll see the simulations in the upcoming sections. So let's see a quick program to toggle LEDs. Here we first define the LED at pin number 2. So after this we have the void setup. The code here runs for just one time, and we have configured LED as an output by using pin mode. Then we have the void loop function. Here I use digital write function to set LED as high for time duration of 1000 millisecond, that is 1 second, and then LED low as 1 for a time duration of 1 second. Let's compile it, and then I will save in my PC. Let's go to Sketch, export compiled binary file. I will do this. At this, I will open PixMLab and then go to File, load the hex file. Yeah, we'll select this and open. Then in the modules, I will go to spare parts and I will select output as a LED. So go to its property and have to see which pin I want. Yeah, pin number 2. Assign it in color. Pose white, click OK. You can see blinking, that is turning on and off continuously. So in this program we will control the brightness of LED by using LDR sensor. We define garden light and LDR pin 11 and A1 respectively. Then we have the void setup. In this we have used pin mode function to give garden light as an output. And we have unsigned it for ADC values, so it will change as per the ADC values. We have void loop, and we have analog read for A1, that is LDR. So the value changes as the values of LDR changes, the brightness also changes by the scale of 4. Then we have an analog write function. We have written garden light and ADC values in it at a delay of 50 microseconds. Let's load the hex file. In spare part, select LEDs, place here. Then we have LDR. Let's quickly change the property of LED at pin 11 as we have mentioned in the program. Click on OK. In LDR we have assigned to I think A1 pin, so let's give A1 pin number 3, press enter. Now you can see as the resistivity decreases, brightness also decreases. So hope it's clear. So this program is for the PWM simulation for LED. We first define the LED pins 3, 5, 6, 9 and 10. Note all of these are PWM pins marked in star. So you can see in PixelLab. Now let's come to the code. Here we define the delay for each LED using constant unsigned integer. Here we have delays. Then we in the void setup we will define the LED as output. All of the LEDs will work as output. Then in void loop function we will just run the PWM for all LEDs simultaneously by using analog write function. So I have assigned all the LEDs analog write function for a value of 0 to 255 with a delay for each LED as same. So in this program what will happen? Let's export the file, then see. Let's load the hex file, open that. Then we will go to spare parts and output. Our output is our LED. Let's quickly set up all LEDs as per the program which we have just written. We have assigned all the PWM pins 3, 5, 6, then 9, then 10, and to distinguish between them, let's assign them different colors. So let me set up all these things. So yeah, everything is set up. Click OK. So here you can see that the rightmost pin will get brighter in lesser time. Yellow LED will get brightest in lesser time due to less delay, and more value is written on the yellow pin, so that's why it will get brighter in lesser time. So yeah, we have successfully implemented PWM on LEDs. So let's see another program to print a string on the CLCD. Here we first use the library y.h that will provide I2C serial communication. Then we use Liquid Crystal library. So to install that, we can go to library manager, and here you can see Liquid Crystal I have installed. All both the libraries are included in my INO file. Then we will create an object called LCD, and again this is a 2x16 LCD. Then we have a voice setup. Here the code run once. We will initialize LCD. Then we have backlight initialization. Then we have clear initialization. Then we have home initialization. And after this, we will set the cursor at position 0,1. That means it will be printed in second row from first column, and here is the string that will be printed, and the void loop is kept empty so that it can be printed for infinite duration of time. Let's compile. Then I will save this. After saving this, we will export the compiled binary file. Let's quickly open the PixelLab. So in PixelLab, we will quickly load the hex file, but before that we'll go to spare parts and output, and I will choose LCD that supports I2C serial communication. Set up here. So now we have set up here LCD. Go to the Arduino datasheet. Here I have marked that Pin A4 will help in STA communication and A5 will help in SCL communication, which we have included by using wire library. So let's go to its property, and at pin number 14 we will use A5 pin, and at pin number 15 we will use A4. Let's click OK. Now I will load the hex file. So go to file, then load the hex file, click on bootloader hex file and open this. So yeah, you can see the string that I coded is being printed. So this program is used for printing the temperature from temperature sensor on CLCD. First, use the necessary libraries for I2C communication, wire.h and liquid crystal.h to display the readings on CLCD. And we define temp at A1 pin. After defining this, we will create object LCD of class liquid crystal I2C.LCD. This is a 2x16 display. So we'll say void setup. The code is run for the single time. Then we will initialize LCD. Then we will initialize the backlight, initialize the clear and home for LCD by using these functions from the library of LCD. Then we will set cursor for printing the string at 0, 0 position, means the top left position of the LCD display. Then we will float the temperature, as it can be a decimal value as well. So in void loop the code runs repeatedly. So here we will have temperature that will be floated value. So using analog read function we will just float this and decrease the values. As we have scaled it by 5, then we will use a string temperature to initialize temperature in the function of string. Then we will use LCD dot set cursor and print temperature on LCD display. Let's quickly compile this. After compiling, we will go to Sketch and export the compiled binary file. Let's open the Pixel app. Here I will go to the spare parts first. So we will use output as a LCD display which supports I2C communication. This is a serial communication. So then we have the temperature system. Let's fix this here. Now we'll go to its property, and as we know we have the SCL pin, so connected at A5, and SDA pin should be connected at A4 as we learned in previous simulations. Click OK. Then in temperature system we will set the values that we just assigned. I assigned it A1. Let's see. Yeah, we have initialized it A1 pin. So we will use A1 pin only. Let me go to its property. Yeah. So here at temperature we will use the pin A1. Let's press OK. And I forgot to upload the hex file. Let's load the hex file. Select this hex file and then we will open it. So yeah, here you can see temperature. So in this program we will display the fill tank and empty tank and volume of water on CLCD. First include wire and liquid crystal libraries. When we initialize the liquid crystal I2C communication, we define the input pins at inlet valve and outlet valve at particular indexes. Then we have sensors. Then we define volume at 0, cross 3. Then we define enable and disable pins and unsigned int and char values for this. And we have the void setup. Void setup, the code run at single time. So we have to set serial data communication, and then we initialize CLCD for establishing necessary connection. And we have the char function. Then we use void volume. This is used to serially transfer the data of volume to the CLCD, and it will be displayed as volume equals to the volume, and then after that we will display liters. Then when filling start, the inlet valve is enabled and the outlet valve is disabled, and the printing will be filling string. In the do function we set the serial write high float. Then when it's starting emptying, the outlet valve will be enabled and the inlet valve will be disabled, and the print statement will print emptying on the CLCD. And again in the do function we will write the serial data as low float. And then in void loop we will start filling again and the code continues, start emptying again. Let's compile. Save this and then go to Sketch and export the compiled binary file. Now you go to Pixelab. Let's quickly load the X file. So we have loaded the X file. Go to module, spare parts, and then in input we will select, in output we will select the CLCD. Let me quickly set up this in the center. Then changing its property, we will select SCL at pin A5 and SD at pin A4. Let's click OK. Then I will go to tools and bring the serial remote tank. So I have already set up my virtual driver, so I will configure that first. On Arduino side it will be COM6 as per my configuration, and at serial tank side it will be COM7. So let me select COM7 as per my configuration. Let's connect it. So you can see when it is start filling, let's press the reset button to establish more viable serial communication among the serial tank and Arduino. So yeah, you can see when it is filling, the volume is getting increased in liters, and after 3000 liter it will be emptying, and the same will be displayed here also. So again, when the tank is empty, it will display 0 liters, and again the same process will start of filling the tank. Next requirement, that is we have to create a Blink application that will serve as a connection between the hardware and the software, so we can directly control using the Blink app. So this is the final program or code for the project. Here I have included many files that are header files and .cpp files, so that our program don't become bogus and we can easily solve any error if it happen. So you can see various files such as temperature and serial files. So let's come to the code. Here we define Blink template and name and token for connecting to the Blink IoT app. Then we include necessary files such as SPI, Ethernet, Blink, Simple Ethernet, Wire, Liquid Crystal Main, Temperature System, LDR, and then serial tank. Then we authenticate the token using char function. Then we print the bool function for inlet and outlet valve. Then we set the Blink timer, Liquid Crystal display, and to turn off and on the cooler we will use the virtual pin. So here you can see to turn off the heater, again we have defined the virtual pin. So using the param.asnet value we can do that, and we can turn it off and on the heater, and the same will be displayed on LCD. Now to turn off and on the inlet valve we will use Blink write and again virtual pin function to show the inflow and inflow off, inflow on and inflow off on the CLCD display. Then to turn on and off the outlet valve we will again assign a virtual outlet pin, and then we will display outflow on and outflow off. Then we have the void update temperature, which will continuously update our temperature on the Blink IoT app. I've used a function blink.virtualWrite that will write the temperature continuously. So for reading the temperature, we have assigned these files that will print the notification of heater on and heater off. So to control the water volume above 2000 liter, what we have done is that we have set up a void function again, so that if volume of water goes below 2000 liters, so it will automatically fill the cereal tank, and these things are all included in that only. You can see in the main file, these all are virtual pins assigned in the program. Then we have the void setup for Blink Begin. We will first authenticate the token, then we will initialize LDR temperature sensor, then timer for that LCD, and we will set delay for the program to be executed on the CLCD. Then finally we have the string for temperature. We have defined that, and in the void loop function we have to control brightness and temperature, and then we will print temperature and tank volume on the CLCD display in the final simulation. So Blink Run will execute our file on that is our IoT app that we will using. Let's compile. The file is compiled. Now I will go to Sketch and export the binary file. So let's come to the simulation. Here we will load the X file that we just compiled and exported. Then I have already set up the window for the spare parts. So here you can see the spare part window, and the heading home automation will be displaying temperature and volume. Here you can see temperature and volume. Then the same is displayed in cereal tank window. I'll open my Blink IoT app. Here you can see cooler switch, heater switch, inlet, outlet, and temperature gauge indicator. So let me first simulate LDR. You can see LDR being simulated successfully. So it decreases, the light also decreases. Now I open the cereal tank. So let's simulate the cooler. Click on. So cooler is on. It is showing cooler is on CLCD. Then I will off the cooler. Again I will on, off, on, off. So you can see that here it has been successfully displayed. Then I will turn heater on. Then the temperature will start increasing. At 35 degrees Celsius the heater will turn off. So you can see after 35 degrees Celsius the heater will automatically turn off without using the switch. So heater is turned off. Heater off notification is showing on CLCD. So now let's discuss about cereal tank. So we have inlet and outlet valve. This is the inlet and outlet. The upper one is inlet and the lower one is outlet. Let me on the outlet valve. So you can see water is going out. The same is displayed on CLCD also. And I have turned on the inlet valve. So it has a capacity of 3000 liter. The same is displayed on both the sides, that is CLCD and the window of cereal tank. Then again I am turning on the outlet valve. Here you can see outflow on. So yeah, we have successfully done that. And after 2000 liter, what will happen is that the inlet valve will automatically get on. So here you can see inlet valve will automatically get on. You can see inflow and outflow command on the CLCD itself. Thank you.